Matching is a part of a three-step process of cleansing, matching, and merging, and is a key part of the data quality process. Since the entire process is a complete task, we will deal with this topic over several tutorials. In this tutorial, we will explain the concepts of matching, which is done using the unification step. The example used during this tutorial can be found in the folder Match and Merge, which is in the DQC Tutorials folder that can be found within the product. This file contains several steps that each perform a different function. These steps, for example, cleanse the data. To perform the match and merge process, we expect that the data is cleansed and enriched as much as possible. The data cleansing process is explained in an earlier tutorial. We will be looking at the unification step, where the match process is configured. Here is the sample input data. Notice that some of the records are similar to each other. Some of these records likely belong to the same person. However, it is not as simple as just assuming that all records with the same name belong to one person, especially in a real-world scenario in which a dataset may contain millions of records. Matching refers to the process of grouping similar records together in order to determine which records belong to the same physical entity, such as a person, company, address, or product. In DQC, matching is performed using the unification step. To find all records that should be grouped together, we could go row by row and compare each record with all others, but DQC uses a more efficient and sophisticated method. This method consists of phases in which records are first grouped roughly and then more finely. The first phase is to create what are called candidate groups. Candidate groups are created by grouping records that have the same values in certain key fields, such as Social Security number or a combination of last name and address. During the candidate grouping phase, we are not so concerned with matching the records exactly. We just want to create some general groupings of similar records. There is a significant performance benefit to performing the process in two phases. Let us look at how this is done in DQC. In the tutorial provided, we use the union matching method, which is one of the grouping strategies. It adds all records having the same key values of the given union key to the same candidate group. Each union key may be a combination of several fields or expressions. Here we are grouping records that match in any of four different keys, containing fields such as social insurance number, credit card number, name, and address. A key is created by adding a key, then adding a component for each field to match upon. Let us run the plan and look at the candidate groups that are created when we use these settings. You see the candidate group numbers that have been assigned in the column called Uni-Can-ID. We see that it has created two separate groups of John Smith records based on the fact that they have different values in the key fields we specified. We will next begin our second level of grouping, creating client groups, which provide the ability to specify more sophisticated rules, including tolerance for typos or alternate word order in different fields. DQC does this by trying to create subgroups from within the candidate groups, which are even more closely related. These subgroups are called client groups since they try to represent an actual client or person, rather than just candidates for the record. Let us see how this is performed. Creating client groups is done in two steps. First, a record from each candidate group is chosen to be the center or center master record for that group. Then all other records are compared to the center master record to see whether it should be considered the same. If a compared record is similar enough to the primary record, then it is assigned to the same client group. If it is not similar enough, then it is called an iterative master and assigned to its own client group. The manner in which records are chosen to be master records utilizes a method called the center selection rule, which is specified in the unification step. In more advanced cases, center selection rules can be defined separately for different matching methods, but in the tutorial example, we use the default center selection rule to apply to all cases. We can see that there are two center selection rules defined. The first rule is the column score_instance, which is the cumulative cleansing score that was generated during cleansing. In general, a higher number means more transformations were necessary to cleanse the data, meaning the reliability of the cleansed data with a high score is diminished. Therefore, as our central records, we want records with lower scores, since they tend to be the most reliable records. In the case that records have the same instance score, the one that was updated most recently will be used, as indicated by the second center selection rule. Now that we have defined our master candidate records, we want to compare each record in our candidate groups to its respective central record. To compare the candidate group records to each other, we will use the matching rules section of the unification step so that we can determine how similar the records are to the central records. Matching rules are specific tests for comparing similarity between records. Let us look at our first matching rule. From the name, you can see that we will be inspecting the social insurance number, or SIN, the last name, and the first name. Records that have identical values to the central record in these three fields will be marked as the same. Records that don't will be passed to the second test, and so on. Records that fail all tests will be considered as separate records and will be placed into new groups, so-called iterative master records. One thing to note, that even after the cleansing process, there still might be some small errors in the data. Therefore, we sometimes want to allow for some minor differences between values. In the third matching rule, tolerances are created for very small differences in values, such as 2 letters or characters being interchanged. The result is 2 slightly different records still being marked as identical. The maximum allowed parameter can be used for limiting the amount of difference, while Levenshtein and Hamming distance functions can be used to determine the magnitude of these differences. In the example, the limit is defined directly inside the expression. These functions are explained in the help section and can be looked up by pressing the F1 key. Let us take another look at this plan's match results output and view the client groups created. We have labeled the client group column uni_CLI_ID. We can see that the groupings are the same as they were for the candidate groups, so no new subgroups were created. In real-world situations, there may be cases where we will need more client groups in each candidate group. Don't forget to change the default max iterations parameter. This parameter specifies the maximum number of client groups in one candidate group. We will describe this parameter in a future tutorial. Let us quickly review the process of matching records in DQC using the unification step. First, we create candidate groups using the key section of the step properties. Next, we define central records, or master records, using the center selection rules, such as score or last update time. Finally, we create rules for testing whether the records within each candidate group really should be marked as belonging to the same record. We do this by creating matching rules. If a record satisfies the criteria in a matching rule, it is said to belong to the same group as the central record. If it does not satisfy any of the criteria, then it is assigned to a new client group and deemed to represent a different entity than the central record. In this tutorial, we have described the match process in DQC. Future tutorials will cover additional aspects of matching and merging in DQC.